Hi everyone, my name is Professor Oaks and this video is about factoring polynomials. Alright, so here is the first polynomial we're going to factor today. So it's u squared plus 8uv plus 16v squared. So this has three terms here. So what you usually need to do when you're looking at what to do about factoring polynomials with three terms is figure out how to break up this middle term so that it's two terms, so that there will be four terms total, so then you can use factoring by grouping. So what you do is you look at the coefficients of the three terms. So we have 1u squared, and we have 8uv and 16v squared. So I'll label these: a is 1, b is 8, c is 16. Alright, so I need to multiply the a times c. So this is called the a times c method. It's one of the methods for factoring. There are definitely others, but this is one of them. Alright, so a times c is 16, and then I need the factors that multiply to get different numbers that multiply to get 16. Well, that could be 1 times 16. It could be 2 times 8. It could be 4 times 4. It could be -1 times -16. It could be -2 times -8. Or it could be -4 times -4. But then I also want the pair where the sum is b is equal to 8. Alright, so I need to add these numbers together now. 1 plus 16 is 17. 2 plus 8 is 10. 4 plus 4 is 8. -1 minus 16 is -17. -2 minus 8 is -10. -4 minus 4 is -8. So I want the pair where the product is 16 and the sum is 8, the middle number here. And I see that it's 4 and 4. So I'm going to rewrite u squared plus 8uv plus 16v squared as, instead of 8uv, I'm going to use the two 4's to write it as 4 equals, right, equals. I want to make sure that looks like an equal here, just so that there's no confusion later, right? Alright, so equals, that's even worse. What a time to be alive, right? Alright, so 8uv is 4uv plus 4uv. So that's still the same, right? It's still 8uv. So this is u squared plus 4uv plus 4uv plus 16v squared. And now I can see that I can use factoring by grouping. So in the first two terms, we have a GCF of u. In the second two terms, a GCF of 4v. So if I factor out a u from the first two terms, I have u times u plus 4v, and then plus 4v. If I factor out the 4v, I have u plus 4v. Then I see that both of these two terms have a u plus 4v. So I have u plus 4v times the, once I divide out the GCF here, the u plus 4v. All right. So times u plus 4v again, and I could write that as u plus 4v squared if I would like to. But in either case, u plus 4v is one of the factors. Let's try again. We have 16z squared plus 40z plus 25. So A is 16, B is 40, C is 25. So I want to use the AC method again. So A times C is 16 times 25. All right, so then 16 times 25 is 400. So I want numbers that multiply to get me 400 and then add together to give me the middle number of 40. So let's start at the 20 times 20. Well, 20 times 20 is 400, but 20 plus 20 is 40. So I already found the numbers. I don't need to go on any further. Like I could have tried 1 times 400 if I wanted to, right? But then 1 plus 400 is not 40, it's 401. So that is not the right choice. So I know that there's lots of other choices I could have chosen. Like I could have even chosen 2 times 200. That would have been 400, but it wouldn't add to 40. It would have added 2 plus 200 would be 202. All right, so I want the product to be 400, but the sum of the two numbers to be 40. So now, what do? I'm going to get another piece of paper here so that you can continue down this journey of learning factoring with me. All right, so now we have 16z squared plus 40z plus 25. I'm going to split the 40z into the 20z plus 20z, and I got 20 and 20 from up here, all right, plus 25. Then I look at the GCF of these two terms here, and I see that it is 4z, because 4z is what goes into each of these two terms here. So I have 4z times 4z plus 5. Here, the last two terms, I have a GCF of 5. So plus 5 times 4z plus 5 when I factor out the 5. Now I see that I have a GCF of 4z plus 5. So if I do this, I have a 4z plus 5 times, once I divide out the 4z plus 5, I still have 4z plus 5 left. So 4z plus 5, and I could write that as 4z plus 5 to the second power. So that means that the 4z plus 5 is one of the factors. So I hope that you really enjoyed that example, because there's still more to come here. So let's try another example here. We have 16t squared minus 24t plus 9. So we have the A is 16, B is negative 24, C is 9. So we have the AC method here. All right, so A times C is 16 times 9. So 16 times 9 is going to be 144. But then B is negative 24. So we need numbers that multiply to give us 144, but add together to give us negative 12. Well, let's say we have 12 times 12. That is 144. But 12 plus 12 is 24. So that's not right. But we could try negative 12 times negative 12. That's 144. Then negative 12 minus 12 is negative 24. Well, that looks to be the correct choice. All right. So now, what do we have here? We have, what do we have? We have 16t squared minus 24t plus 9. We can rewrite that as 16t squared minus 12t plus 9. If we look at the first two terms, the greatest common factor happens to be a 4t. If we look at the second two terms, the greatest common factor is -3. So if I factor out a 4t, I get 4t times 4t minus 3 minus 3 times 4t minus 3. Then I see the GCF is 4t minus 3. So if I factor out 4t minus 3, then I have 4t minus 3 times what's left, 4t minus 3, and I can write that as 4t minus 3 squared. So 4t minus 3 is one of the factors. So I hope that you enjoyed this here. So let's try another one here. So we have 64t squared plus 49. So here is 64t squared plus 49. I notice that the 64 is 8 squared, and the 49 is 7 squared. So I have 8 squared t squared plus 7 squared, and I can write 8 squared t squared just 8t all squared plus 7 squared. And then I see I have two squares added together. If I have two squares added together, so the sum of two perfect squares, that cannot be factored. All right, so whenever I see the sum of two perfect squares, this cannot be factored. So there we go. Let's try another one. Here we have 9 minus 49x squared. 9 is 3 squared. 49 is 7 squared. So I have 3 squared minus 7 squared x squared. I can write the 7 squared x squared is just 7x all squared. But then if I have two perfect squares, the difference of two perfect squares can be factored. So the formula is a squared minus b squared is a plus b, a minus b. So I have 3 squared minus 7x squared. So the a is 3, so 3 plus 3 minus, and the b is 7x, so 7x, 7x. And then I can see that one of the factors is 3 plus 7x. All right, let's try again. We have 16x squared minus y squared. I see the 16 is 4 squared, so I have 4 squared x squared minus y squared. But the 4 squared x squared can be rewritten as 4x all squared minus y squared. All right, then I see I have the difference of two perfect squares. So then I use the formula again. A squared minus b squared is a plus b, a minus b. So this is 4x all squared minus y squared is equal to 4x plus y times 4x minus y. Then I see that 4x minus y is one of the factors. Hopefully you enjoyed this, because we're not done yet. Don't worry, we're not done yet. We have more. There's always more. So let's try another one. Alright, so actually, you know what? I actually don't think that there's any more left today because I did all of the different types that you might see in this section. Some examples involving the AC method. And then if you have a sum of two perfect squares, remember that you cannot factor the sum of two perfect squares. Like this example here, you cannot factor the sum of two perfect squares. And then we did the difference of two perfect squares as well. So that's it for today, everyone. I hope that you enjoyed this video and that you're already looking forward to the next one. Thank you and have a great day.